All right, here we are in section 11.3 on quadratic equations. So our objectives are learning the basics of quadratic equations, applying the square root property, completing the square, solving an equation for a variable, and then solving applications of quadratic equations. So basics of quadratic equations. Any quadratic function f can be represented by f of x equals ax squared plus bx plus c. Again, a cannot equal 0 or we don't have that quadratic. Now examples are f of x equals 2x squared minus 1, g of x equals minus 1/3 x squared plus 2x, and h of x equals x squared plus 2x minus 1. So any of these are, quadratic functions or quadratic equations. Now, a quadratic equation is an equation that can be written in the form ax squared plus bx plus c equals 0. And again, the a cannot equal 0. Now, the different types of solutions to these quadratic equations are there's no solution, so there's no intercept. There's only one intercept where it touches at the vertex, basically, and there's two intercepts where it touches somewhere along the parabola in two places. Now, it doesn't only mean that it can only be up, it could also be the same way like this. We could come up over here and we could do something like that. So it doesn't mean that's the only way it looks. It could be facing down or up depending on what it is, and it just means that there's going to be two intercepts in this case. One intercept here and no intercepts here. Now, what they want us to do is solve each quadratic equation, support your results numerically and graphically. All right, so 3x squared plus 2x equals 0 is our first one. And so we have three ways we have to do it. So symbolically, we just have to solve. We have to take, well, okay, take the 2 over, take the and divide by 3, and now we have to take the square root. But you know what? We can't take a square root of a negative, so there's no real solutions, okay? So x squared is always going to be positive, so that means there's no real numbers x that's going to solve for this one. Numerical, well, we're going to plug in some values, give us a table, and then after that, we're going to actually graph them. And when we graph them, guess what? It's all above the x-axis, and therefore, it's not going to have any solutions. It's only going to have no solutions in this case, which all three show the same thing. What about B? Well, B, what we have to do is we're going to have to take that 6x over to the other side, and then we have to see if we can factor it. Well, this one nicely factors into x plus 3, x plus 3. And when we set each of those factors equal to 0, we get x equals a negative 3 or x equals a negative 3. And so therefore, there's just that one solution at x equals negative 3. And so now we better include negative 3 on our list of tables because otherwise we won't actually find it. And we're going to find that negative 3, 0 is going to be our vertex. And as we see graphically, when we get that graphed, it is going to be our vertex. And so that shows it's just the one solution. Now, what about our last one? Again, we try to factor. Well, it nicely again factors into x minus 2, x plus 4. And so set each of those terms equal to 0 using the zero product rule. And we get x equals 2 or x equals a minus 4. So that has two solutions. And so what we have is we plug it in and we better go at least from minus 4 to positive 2 because that's going to be the key pieces here. And so we plug all those in. And guess what? That's where those two hit the x-axis as we do the graph. But the vertex is way down here. And so that's at the minus 1, minus 9. And then when it goes up, it's going to be like that. And again, we would expect that because it's going to be a min with a greater than 0. All right, so let's stop there and we'll come back for some more.